I have 55, I have 5. Plus, what I'm going to do is I'm also going to create these, some loopbacks that I'm going to use later on. I'm just going to change this to 205 and then make them OSPF networks. These are all 205 networks, not 201. That's the difference. All right, so I'm going to add that in the network statement over here as well, 205.1.0.0. This router has all its links in area 20. Copy it. Let's go to router 5. Yes, it is. So if my neighbor is up, I should see the routes from area 0. Hmm. 35.3. That's right. Oh, did I do 20? That's the problem. It's all 10s. So what I'll do is everything is in 10. Copy it. Go to 5. This should all be in 10. This side was all area 10. Now I should see the routes in a bit. On my local routes, OSPF is a little slower than EIGRP, so all my inter-area routes are coming over here. And R2, I should also see those 205 routes popping up. There you go. All right. Now let's do 6. Very similar to what I did over here. .6. It has another link which is connected to router 7, so 67.6. I don't need to worry about this. .46, and this is all 10, 20, sorry. This would be 66, this would be 6, this would be 6. Copy it. Let's go to 6, launch that up. Almost done. Let's check our OSPF neighbor. Show IP OSPF. We'll route OSPF, all the OSPF routes, including the routes from 5. Any local route shows up with an O. Any route coming from another area shows up as an OIA. 6 is done. Now the next thing that I need to do is 7. Seven is a router that connects to RIP on one side and OSPF on the other. So I'm going to keep this in RIP 7. This one I'll keep in OSPF. F0 is connected to 67.7, and this over here is S, which is 78.7. This is going to be 67. 77, I don't have these two networks. I don't care about these loopbacks over here. The rest, I'm going to run router RIP, version 2, no auto, network, 1.78.0, and I'm going to advertise a 7 network in here. So they have something for RIP as well. This looks good. Show IP OSPF neighbor. Oh, this is not communicating. Yeah, it doesn't have 67. Should pop up now. Should have 77 over here as well. There you go. Takes care of that. '77 is over here. Now the last router over here is the RIP router on the edge. On the last router, I'll put 8. This is all going to be RIP, so 88, I'm going to take this off. I don't have a Ethernet, I have a serial. None of this. This is all RIP, 72, 78, sorry, 8, 88. If you want, we'll also put these networks in here. These networks will say is 100.1. 100 dot whatever that thing is, 1, 5. And this is going to be network 100. Copy it. We'll go to 8. Show IP route, RIP. Let me just go over here to check how many routes have I received. 100, 4, 5, 6, 7, and 8, and 88. So my topology is set up over here. Based on this particular topology, we'll be doing different things that we need to cover today. This one. Our objective today was to do this. I'll copy it and put into our notes for today, which was this guy over here. Okay. I'm not doing 1 and 2. We've done that already. We'll do 3, 4, and 5. So first thing is to check the LSA database. I'm going to do that on R5 first. I want you guys to notice that it will only have one LSA database, which will have type 1 and type 2s. It would have received type 3 from R3. Let's take a look at that. Show IP OS database. You can do that and it'll show you all the different basically the number of router link LSAs that you have, network LSAs that you have. It'll show you all of them. Okay. It will also show you the link count each one is advertising. For example, it's telling you that router 3 in this area is advertising 2 links. Router 5 is advertising 7 links. You also have one network link LSA in area 10, which is basically advertised by 3333. That tells me that R3 is the ABR between 3 and 5. There's only one multi-access segment in this particular area. All right. And it's also getting a whole bunch of other links from where? From somewhere else. These are called summary net links. If you want to keep it a title, this guy over here is your type 1, which we did the last time around, type 2, and these are your type 3s. Names: router, network, summary. These two combined make up the O route in your routing table. This one basically gives you OIA, inter-area routes. But notice on R5, I only have one database for area 10. Why? On R5, it's an internal router, which is part of area 10. It has all its links in area 10. So it's only going to have one database for area 10. Now, let's do a detailed look at these routes, like we did the last time around. If I want to take a look at a detailed look, I say show IP router, show IP OSPF database router, shows you your type 1s. It shows you that R3 is advertising 2 links, the network 3 and the 35. R5 is the other router in this area. It's advertising 7 links. Which ones? 205.1.4, 5, 6, and 7. Those 4, the 5 network, the 55 network, and the 35 network. All right? That's all I have in area 10 because I broke it down into a small area. If I want to check my network LSA, you guys tell me how many network LSAs should I see over here for area 10? How many network LSAs for area 10? Whether it's on 3 or 5, for area 10, it's going to be common. How many network LSAs, guys? 2? How many DRs do you have on area 10? 1 DR. So 1 DR means 1 LSA type 2. The DRs are the ones that propagate the LSAs. Okay? So that would be 1. You can check that out. How do I check it? Right over here. That's the one. That's network 35, the multi-access segment, which has 2 routers connected to it, 33 and 55. Good? Now, if I go to 3 and check the same thing, it's an ABR. So if I do show IP OSPF database over here, you will notice it has 2 databases. It has a database. Let me finish the space bar first, then I'll scroll up. It has 2 databases over here. What are the 2 databases? It has the same database that you found on R5 for area 10, plus it has the same type 1, type 2, type 3. Those are the networks that are part of area 0. The 3 links that it's advertising in area 0 are from router 2, router 3, and router 4. 3 links advertised by 2, 2 links advertised by 3, and 2 links advertised by 4. Plus it has 2 network LSAs. Why 2 network LSAs? Let's take a look. How many multi-access segments in area 0? The 192.1.23.0 network, Ethernet, 192.1.24.0, Ethernet. Those 2 are the 2 DRs that are advertising. And 1 network LSA, you'll have 23 with router 2 and router 3 listed as the 2 routers. And another one will be for network 24, which will be router 2 and router 4 listed as the 2 devices on that particular network. Clear? Coming back over here, that is the database for what? Area 0. Notice it is for area 0. Everybody okay with that? So when you're looking at this database, I want you to check to see if you have the right LSAs or not. These are the links that are advertised by other areas. Clear? And if I scroll down, what do you guys see over here then? Same information, type 1, type 2, type 3 for what? Because it's a member of two different areas, it's going to have complete databases for each one. But this is the one that will be exchanging these routes with the other area. You guys okay with this? Now, how many type of routes do you see over here in this database? How many type of LSAs, I should say? Help me out, guys. How many type of LSAs do I have over here? 3. What are the 3? The router, which is type 1, type 2, and type 3. In a pure network which is running just OSPF, you're going to have type 1, type 2, and type 3 only. You're not going to have 4 or 5 or 7. It's just 1, 2, and 3 in a pure OSPF only type of network. If you have a single area, you'll just have type 1 and type 2s. If you have multiple area, you'll have type 1, type 2, and type 3. Is there a chance that you just have type 1? Yes, if your routers are connected to each other using serials, there's no multi-access segment. For example, if I had a network like this, these are your LAN segments, these are point-to-points. But on the LAN segments, I don't have any DR election, so in this case, I'll just have type 1s. Single area. Type 1 will always be there. Whether you have a type 2 or type 3 depends on certain requirements. You only have a type 2 if you have what? Multiple routers on a same segment, and basically your multi-access segment, you would have a DR. Type 3 if you have multiple areas. Cool? You guys okay with that? So help me out with the topology now that you guys are experts at the database. I want you to tell me, what do you expect to see as a database on R6 over here? How many type 1s? Roughly. Let's say this is these are my networks over here. How many type 1s on R6 or in area 20? Because that database is going to be consistent within area 20. How many type 1s? Just 2 type 1s. 5? I say 6. 1 over here, 2, 3, 4, 5, and 6. Okay. Now somebody said 2, Delano and Consolidate. I don't see the rest of it. They said 2. That is for type 2. Good. Type 3 is bunch. All the routes that are not within 20 will show up as type 3. But it'll only have one database on R6. It'll be for area 20. It won't have multiple databases. Let's check. Show IP, OSPF database. I'll just do a normal one, the full one. 20, the different links. Actually, I have more because I listed those other networks over here. I was under the impression I just had 4. Remember, I have those 206 networks as well that I've advertised for. Later on, I'm going to do summarization. So I have that. This is why type 2, the 2 for the 2 multi-access links, and then a bunch of what? Summary LSAs. Clear? Everybody okay with that? You guys are comfortable with the OSPF database to see it. And if you want to see what network type LSAs that you have, you can always complement it with the network statement, and then you'll get the 2 LSAs and the routers connected to it. Good? Everybody? The next thing I want to do, if everybody is okay with this, I'm going to do the redistribution of EIGRP and RIP into OSPF. Don't worry about how it's done because I'm going to have a class specifically for redistribution. At this point, my main objective is to get these external routes in. External routes are routes that are redistributed into OSPF. Okay? When I redistribute any routes into OSPF, those routes are external routes. And the router that does the redistribution is given a designation of an autonomous system boundary router, ASBR. So let's write that in your notes. Which one was that? The untitled one. ASBR. Any routes that are redistributed into OSPF are known as external routes. These routes will be injected as a LSA type 5. All right? Cool. The redistributing router is known as the ASBR, Autonomous System Boundary Router. Cool. You guys okay with that? So let me go ahead and do the redistribution simple on R2. And as I said, I will go into detail about the redistribution itself, the different things to keep in mind. But for right now on router 2, which is connecting my EIGRP domain to OSPF, I'll say redistribute OSPF 1, metric, the EIGRP 5 metrics, bandwidth, delay, reliability, load, and MTU. Router OSPF 1, redistribute EIGRP 100, subnets. In the redistribution into OSPF, you need to have the subnets keyword, otherwise it just redistributes major networks. You don't need to have a metric because the default metric is 20 for redistributed routes. As soon as I do that, my routing table now will be different. You will see a bunch of what? E routes. I'll do an include statement so we can filter it a little bit. Include O E2. So these are all your external routes coming in from the EIGRP domain. I'll do the same thing on R7, the other redistributing router. Router RIP, redistribute OSPF 1, metric 1, router OSPF 1, redistribute RIP, metric, I don't need to put the metric, just the keyword subnets. So now 5 should see a bunch of other routes as well. Give it some time. It is OSPF, so it's not as quick as EIGRP. Takes some time for these routes to propagate. Good. So now you see a bunch of different routes. The 8s are coming in. So I did the redistribution where? On the 2 edge routers, the routers that are connecting 2 different routing domains to each other. So my redistribution was done over here. I did mutual between EIGRP to OSPF and OSPF to EIGRP. Same thing over here. Now these routers are termed as ASBRs. You guys good with that? Now, what do you call it? What LSA do I send with external routes? LSA type 5, right? Type 5 is your external route. Let's check that out. I'll go to, let's say, R5, and I'll type in show IP OSPF database external. This is going to give me detailed information about all my external routes. What is the route that I'm getting over here? The network that I'm getting over here, the link that is getting advertised is network 1 with a mask of 8. Who's doing the redistribution? It maintains the original ASBR as a redistributing router. It basically is telling me that this redistribution took place for network 1 on what router? Router 22. Do you see that? Or R2? Everybody see that? This is very important. This is something that people overlook. This is extremely important information over here. And I'll get back to you why is that information important. But notice the advertising router. Who did R5 receive this information from? For network 1. If you look at your topology. Who did R5 receive the information about the external route from? It does not have a neighbor with 2. 2 is in a different area. It received it from R3, but it says the advertising router is 2. Do you see that? It maintains the ASBR link. It doesn't change. Now let me go down, and you will notice that for every network, you would have the same thing. Network 2 is advertised by 2. Network 7 is advertised by 77. You guys good with that? With external routes, the originating ASBR maintains its advertising label throughout the OSPF domain, whether it's in a single area or multiple areas. Now the problem over here is that R5, I'm on R5, has no idea who 2 or 7 is, do they? These are router IDs. The router IDs don't belong to their areas, they belong somewhere else. Where do they belong? 2 belongs to area 0 and 77 belongs to area 20. Take a look. These are routers. 7777 or 2222 is the router ID of the routes. So basically what I'm saying over here in that LSA, that R2, R2 advertised that external route, but R5 has no idea who R2 is because he only maintains the reachability of the routes in the local area. So R2 does not know if that information is correct or not, and even if it is, how do I reach R2? For that purpose, what the ABR does, the function of the ABR over here is if the ASBR is not in what, area 10, it's going to inject a special type of LSA called type 4. Type 4 basically is the link, basically saying that I do have connectivity. I will give you connectivity to the 2 ASBRs that you have, which is router 2 and router 7. So you will have 2 LSA type what? 4s that are going to be sent by R3. The ABR will inject information. Listen, if you want to get to 2 and 7, which are your ASBR, just send it to me. I'll take care of it. So now R5 knows the next stop to all the external routes is through R3. Do you guys understand that? So, but along the same lines, let's say, hypothetically speaking, I have, so over here, how many type 4s do I have? I have 2 type 4s, right? Now let's say I had a router over here. This is my ASBR. Guys, pay attention. This is important. You won't find this in books easily. This is your ASBR, right? How many type 4s do you have on this router X, which belongs to area 0? How many type 4s? Let's see the answers. 1. Chandrasekhar says 1. You guys agree? I thought I had 2 ASBRs. Zero. Does this router X know how to reach 7? Does it know how to reach 2? It does know how to reach 2 because 2 is in the same area. If it's in the same area, it knows how to reach 2. It does not know how to reach the ASBR in the other area. So this guy would have advertised a type 4 for it, for 7. So you would have here 2 and 7. Here you would have just 7. Why? 2 is reachable. It's in the same area. How about over here in this area? Again, same thing. This ASBR is in the same area. So this guy over here would know about this ASBR because he's in the same area. But he does not know about what? This ASBR, different area. So R4 will inject what? Type 4 listing 2. Does that make sense, guys? So 4 is just to get you reachability to your ASBR if the ASBR is not in the same area. If it's in the same area, you would not have a type 4. If I had this type of environment, just to give you an idea, if I had this type of environment, router X doing the redistribution, this is EIGRP, and this is OSPF in area 0, and I'm doing redistribution. The whole thing is area 0. Okay? In this case, you will not have a type 4. Why not? Because the only ASBR is in the same area, but you would have a type 5. Srijil, so type 3 and type 4 is by the ASBR. That is correct. ABR. That is correct. Type 1 by any router. Type 2 by the DR. Type 5 by the ASBR. So let's write that down. That's a good summary to keep. Who advertises what type of routes? LSA injection. LSA type 1, which is the router LSA, injected by any OSPF router, because it's a link state. LSA type 2, which is called the network LSA, injected. Come on, guys, help me out. The DR for each multi-access segment. You guys agree with that? LSA type 3. What's it called? Summary LSA, injected by the ABR. LSA type 4. What's it called? It's called the ASBR summary, injected by the ABR to provide reachability ASBRs in remote areas. What do I mean by remote areas? Not in the same area. If the ASBR is in the same area, I don't need it. Okay, and the last one, LSA type 5, external LSA injected by the redistributing router. Cool? Yes, you can. Absolutely can. And I was going to show you that anyways, but let's check it. How do I check it? Show IP OSPF database. Let's just do a global one first. All right. Summary ASB. And then your externals. How many LSAs for summary ASBRs do you have? 2 in router 5. Why 2? Both the ASBRs are in remote autonomous system or remote areas. For router 5, one ASBR, which is 2222, exists in area 0, 7 in area 20. So if you want to check detail about that, it is the ASBR command. There you go. Now over here it says the link state is 222, which is the ASBR router address. Who's advertising it? The ABR advertising. Now let's do the same thing for router 6. Router 6 has an internal ASBR, which is 7. I don't need an ASBR summary for that. So show IP OSPF database. Let's do the normal one first. So type 1, type 2, type 3, but only one type 4. Why only one type 4? Because 7 is an ASBR in the same area. I have direct reachability to it. So I don't need to link it or I don't need to advertise it. So if I do that ASBR summary, you will notice the advertising router is 4, the ABR for area 20. Only one though. Cool? You guys good with this? These are your LSA types, inside out. You guys feel better about all the different LSAs and how they work? By default, type 5 LSAs will flood in all areas. That is correct. By default, Sam. I can filter it and I'll show you how to filter it in a bit. You guys feel comfortable with the LSAs? Now, let's go back to what I had to do in terms of things. This guy over here. Metric calculation, very simple. If you look at the link cost, it basically is whatever your bandwidth is divided by 10 in bits per second. So let's say this is fast Ethernet over here. Fast Ethernet divided by 10. Fast Ethernet is what? 100 megabits per second divided by 10. You get 10. Again, it is in, what do you call it? If you look at the cost, you can go to any router and check the cost of that link. So let's say I go to router 3, show IP OSPF database router. It'll show you the cost is 10. All right, and it's cumulative. So if I go to router 6 or 7 and check the cost to router 5 or network 5, you'll see it's going to be accumulation of 10 plus 1 for the loopback itself. It's too many routes, so include 5. There's 5, let's pick it, 51. Why 51? Let's analyze it. 10 plus 10 plus 10 plus 10 plus 10, 50. Plus 1 is for the loopback itself. Everybody okay with that? Simple calculation. And it sums it up, adds it. Unlike EIGRP, which is that bandwidth delay, and that has a formula, bandwidth to the 10 to the power of 7 divided by bandwidth minimum. Delay sum divided by 10 multiplied by 256. This is just simple bandwidth divided by 10 to the power of 7 basically. Cool. And now the next one that is more important. Multi-area configuration. Correct, 10 to the power of 8. So multi-area configuration, we've done that as well. That's the topology that I just drew for you guys. So these three are done. Let's do these two, and then we will take a break. Filtering, okay? Within the area, not recommended. Filtering within the area is not recommended. Let me show you that, and I'll tell you why. What gets propagated in OSPF? What does OSPF propagate? Routes or link states? The LSAs. LSAs. Now this is what happens if you do it within the area. I have R4. It has network 4. Okay? It's going to send the LSA for what? For this network 4. Type 1. Network 4 to whom? R6. R6 keeps it inside what? LSA database. You guys okay with that? And then it takes the LSA database and forwards it to whom? To his neighbor as is. Remember, it doesn't change it. It says R4 is saying it has network 4. No DR, yeah, if it's a multi-access segment, it'll send it to the DR. DR will propagate it within the same segment. But if it's a point-to-point, it'll send it to the neighbor. But again, it's going to send it to the next hop. Now, do you remember we did filtering with RIP and OSPF using the distribute list, using the ACL or the prefix list? You guys remember that? Where did we do it? In RIP or EIGRP? How did we do filtering? Remember we had that long discussion about filtering. Router RIP, for example. Distribute dash list. One in whatever. Do you guys remember this? This is how you did filtering. Or you could say distribute dash list prefix ABC in F0/0 on router in RIP or EIGRP. This could be for EIGRP as well. Because I'm exchanging routes. Here in OSPF, I have the ability to do that. But the problem with that is this thing that I did over here, if I did it for OSPF, let's say this was OSPF, this sits between the LSA database and the routing table. This distribute list that I did sits right over here. So what happens is on R6, I get the route into my LSA database. When I'm ready to inject it into my routing table, I'll notice I have a distribute list, and that is preventing 4 getting injected into 6. It will stop it, and 4 will not be present over here because I blocked it based on, let's say, my distribute list. But does that prevent R6 from propagating the route to R7? No, because it still is propagating the LSA. And as I have been telling you, every router looks at the topology. It has complete view of the topology, calculates its own routes. R7 looks at the topology and says, in order to get to 4, I need to reach 4, and 4 is reachable via 6. So he puts in network 4 over here with the next hop of R6. Now, if somebody wants to send traffic to 4, he says next stop is 6. He gets it. He drops a packet. Because he does not have 4. You guys agree? So what it does is it causes unnecessary problems on different routers within the area, because if you do route filtering on an internal router, it just filters a route from the LSA database into the routing table, and you'll do a lot of black holing where R7 still will forward the traffic to what? R6 before it gets dropped. It's not recommended to do that. Can you do it? Yeah. But then you would need to do it on each and every router within that area if you don't want that route, internal route, to get propagated. This is only for LSA type 1. Let's check this out. Let's see if it is the way it works. Let's go to router 4. No, let's go to router 6. 4 is already sending him a route. Let's check it on 6. Show IP route include 4.0.0.0. Notice I'm getting this route, an O route, which is type 1, in from 4. I don't want that route in my routing table on 6. So what do? I can create an ACL or an prefixes, doesn't matter. Router OSPF 1 distribute-list 1 in F0/0. Done? Now I'll go back and do that show command. 4 is gone. From where? From 6. Why? It sat in the middle of the LSA database and the routing table on R4. The distribute list did. But it did not prevent the route getting